My name is Brett Barrett, and I'm a senior delivery consultant with Evolving Solutions. So I don't want to say that my presentation is totally tied to security, but you could say it's tied to risk management in the aspect that we don't want poor end user experience or bugs to get into production. And so we want to mitigate those types of risks. So I'm going to share how you can prevent apps with poor response times, error rates, or just bugs and issues from actually making their way into production with another type of testing you might not actually be using right now. Before I go into that, I want to share a couple pieces of research I found that I thought were pretty interesting. So T-Mobile went through and looked at their own metrics for end user experience to try to understand how poor user experience would impact their bottom line. So I want to start by saying that you see conversions on this screen, and conversion is sometimes an industry term that's used to talk about maybe revenue generating applications or websites. But in this case, just think of conversions as a user meeting the goal that you have on your website. So say, for example, if you're NPR, you might just want someone to subscribe to your newsletter, or you might want someone to maybe donate to NPR or to stand up their own local branch of it. All three of those could be applicable conversions. Only one of them actually has to deal with money. So there's three pieces of research from this blog that I found that you see in the bottom that I thought were pretty interesting. First, visitors they found were half as likely to convert if they had 5 pages that had hiccups. You can see that when there were no hiccups, their users generally converted at a rate of 38%. But if those users ended up getting to 5 pages with issues, they actually ended up hitting an 18% conversion rate, which is less than half the percentage of conversions. Those users who had very quick response times or just better response times ended up converting more often. Big surprise. But I really like this graph where we can see over here the orange dots representing those users who did convert. Their response time is about 66% of the non-converting people, or you could say that the converting speed is 33% slower than the non-converting. Anyway, those people who had slower response times are less likely to convert, as we'd expect. And then finally, I wanted to call out with this graph that first impressions are the most important. We've heard this time and time again, but T-Mobile said, no matter what page people visit that's slow, the 2 pages that are the most important are the landing pages. In their case, their home page and their login page. So you can see where the conversion rates dip as the response time increases. So at the 0 to 1 second range to the 6 to 7 second range, it is just a downward slope. There's the uptick at the end, but I'm going to attribute that to users who already expect a slow performance. Maybe those are DSL users or rural users who normally have a bad time and just let the website take its time. But we can see for these more average types of response times, there is a direct correlation here between response time and people actually getting to that end goal on the website. So I shared that T-Mobile info, but just think about it in your life, in your world. Do you know if your app slows down by half a second, how that impacts your bottom line? So before we get into the meat of this conversation, I'll give you a little bit of information about myself. Again, my name is Brett Barrett, and I'm a senior delivery consultant with Evolving Solutions. So I have been in the monitoring space for my whole career, and I've lived in a couple different aspects of it. I used to work for a software company, a vendor of monitoring products. So I lived on the vendor side, and then I also worked for a Fortune 50 company where I used no vendor products and all open source all the time, all automation. So I've really seen both sides of that, and now I'm with Evolving Solutions, who is a partner company to an APM, to multiple APM vendors. So with Evolving Solutions, if you haven't heard of us before, we're a technology solutions provider that helps clients modernize and automate their mission critical applications and infra to support business transformation. So our business is client-centric consulting and delivery of technical solutions to enable modern operations in a hybrid cloud world. I'll try not to read slides word for word, but this one I want to make sure to hit all of the key points. So what this means when you see some of these buzzwords here or key points is that there are a lot of pieces to this new hybrid cloud world that many corporations are living in. And for us at Evolving Solutions, our hybrid cloud vision is about business transformation, because we are now tasked today, companies and enterprises, with building these new cutting edge, bleeding edge websites and applications that make our users happy. But at the same time, we still have to support our old legacy software or maybe our core business. But we didn't get double the budget and double the team, so we have to do more with less, as is the common adage. So we focus on modern development practices, operations, and using modern platforms. Even today in the presentation that I'm sharing, we're going to be talking about CICD with Ansible Tower and orchestration and automation with Ansible Tower. I suppose in here we could add in quality gates, and maybe even from the previous presentation, you would include security checks as part of your CICD. And then further, we're looking at performance today, so it's part of enterprise monitoring and analytics. And I think that's the main three that I'm going to touch on. But out of all of this technology, it doesn't really do anything without the right people and the right processes. So without those in place, let's see, where do I want to go with that? We have to make sure to drive value to the business. Even if we set up this beautiful architecture, it doesn't mean anything at the end of the day if we aren't making our customers happy. So at the end of this presentation, I have a slide that has my email address and our Evolving Solutions contact through our LinkedIn. So feel free to reach out to me with any questions or see us on LinkedIn and see what else we're up to. So I'll go ahead and jump into my presentation then. I'm going to talk to you about how you can release quality production applications. And we'll start with what the typical software development lifecycle looks like. So generally, you'll have a developer, they'll write some code, and they'll perform unit tests on it. They might put it into a staging environment and then perform some functional tests on it before they release it to production. In this simple pipeline, it tells you that, yes, the app works, but it doesn't tell you how well the app works. You could have an integration test that took 72 seconds to complete, and yes, it passed. You got your expected input and output, but is an end user really going to wait 72 seconds for that operation? Maybe not. So in this pipeline, there's no sense of performance monitoring or any gates there in that sense. We're just looking at ins and outs. Did we do it correctly? So through this presentation, we're going to shift left. Now, if you haven't heard of shift left before, it's a terminology that's been around for a while. I did some Googling to try to find the earliest mention of it, and what I could find is in a 2001 blog post, the mention of shifting left. Now, the idea here is that the later on in a software development lifecycle that you find a bug or a problem or something you want to tweak, the more expensive it's going to be. So there was a study by IBM, and I saw it from a blog post, so you can find the sources below, where they had said, in a scale factor of 1, if you find it in the design phase, you take care of it there. But if you don't find a bug until testing, it could cost 15 times as much as if you had planned for it in the beginning. And of course, worst case scenario, if you don't find that issue until you're in production and you're in the maintenance phase of the software delivery lifecycle, then it could cost you 100 times the initial design. So with this shift left, we are going to add in performance testing. And if I tried to point where we would be on the graph, we would probably be in between this testing and maintenance, because we are going to perform testing, evaluate the performance of those tests, and then if those pass, release to production. By hearing me interject about putting a step in between testing and maintenance, you probably can understand my motivations for asking my previous question about could we introduce OS cap inside of a pipeline to prevent that those vulnerabilities from making their way to production. Kind of these same themes. We don't want to put garbage into production and then find out about it there and then have to spend a ton of money to rework it. We should try to find it earlier, find it fast, take care of it, save money, and spend more time doing fun things as opposed to fixing prod. So a normal CI/CD pipeline might look like this. This is actually a screenshot of an Ansible Tower workflow, and I think it's a pretty good example of showing you what a common path may look like for a deployment or for just a build test. So in here, if you're not familiar with Ansible Tower, you can see that there is a flow chart with passes and fail directions. Your Ansible Tower playbooks may look more similar to this. For today, we're going to be using a simple one just to focus on the performance part of things. So all you need to do to add performance testing into your development lifecycle is to add what is called a quality gate, or sometimes an automated quality gate. And in your pipeline, really, that's going to just be 3 additional steps. So in this case, we have a couple different products that we're using in this demo. I'll get to those later, but at a high level, we need to tell our monitoring tool or our quality gate, hey, we are performing testing at this time, and we want you to evaluate the metrics here. Then we have to actually query and say, did this meet the spec that we desired or not? And if not, then we just roll back to the previous version, figure out what the problem was, try again, and all of this is before releasing to production without customer impact. So by adding these 3 simple steps, you not only know, is it working, but you will know, is it working well? So the updated pipeline just has these 2 here. Maybe I should have put the add deployment event in here as well. So let's talk about the demo. There's 4 key components. So first, I need an application to test, right? We are building integration test, pushing to prod. We need something that's doing that. So in this case, I'm using the app EasyTrace. And actually, I'll go into these in more detail after this slide. We need a CI/CD pipeline, something to help put all the pieces together, build, test further, and then release. So we're showcasing Ansible Tower today. You need a metrics platform or something that's just taking observations about your app to say, are we meeting our response time thresholds or our error rate thresholds or our number of database connection limits? Any metrics that you care about that you would want to investigate through testing, you need some source that is storing those metrics that you can evaluate against. And then finally, you need that quality gate to actually go do the query and do the evaluation to give the thumbs up or thumbs down in performance. So with EasyTrace, it is a Dynatrace demo application that's free. I like using it because it's built by Dynatrace, so it's easy to instrument, and it is a distributed application that has a web front end, middlewares, backends, and databases. So you get a pretty good monitoring view out of it too, just by instrumenting this app. Further, this app has a configuration API that we can call to make changes on the fly. So in our exact example today, we are going to pretend we have a feature flag in our application, and we have not yet enabled it. It was just built in there, but it's sitting idle, it's turned to false. We are going to enable this feature flag, look at the change in performance, and then decide whether it's ready for prime time or we need to roll it back. And then Ansible Tower. So today we're using Ansible Tower. Ansible Tower is the graphical UI version of Ansible, and we can interact with it via APIs and program it however we'd like. I love using Ansible because it's extensible and you can call any other API and do that flow logic and build out the pipeline exactly how you need. It doesn't matter what your underlying technologies are that you're interacting with or how your app is built. Ansible is customizable and will allow you to build out the pipeline that you need to make sure your app is ready to go or is deployed or handled. So in Ansible, like I'd mentioned those 3 steps earlier, we're going to have the initial post to Dynatrace to say, hey, we're going to start testing, pay attention at this specific time frame, so that later we can query that time frame and say, hey, thumbs up, thumbs down, did we meet our performance spec? And then finally, if we did not, then we need to turn that feature flag back off and do a deployment event that says, hey, we're turning this off, didn't look to be good. So in this case, I'm using Dynatrace. It is an enterprise-grade monitoring platform, but you can request a free trial environment for personal use. Dynatrace is a leader of the Gartner Magic Quadrant in the APM space, and I have a bit of experience with it, so I've been using that today. It's pretty simple to set up. What I did is got a trial environment and installed the agent, and then I had to look at Dynatrace and look for the service I care about. So in this case, the feature flag that I'm enabling is changing how the customer login behaves. So I just looked for the customer login service and got its identifier, and then got an API token so that I can query Dynatrace for those metrics. Finally, the piece that everyone is probably the least familiar with is this idea of a quality gate. And maybe in this case, I should call it a performance quality gate, but really you could determine quality however you want. Maybe in the terms of security, you could have a security quality gate where you're running that OS cap to say, yep, good, bad on the vulnerability count. So in this case, this is an open source Dockerized application which interacts with Dynatrace. So we give it where we want to query and tell it what service that we want to hit, and it's going to do the evaluation for the thumbs up, thumbs down. This is where we actually pass it what our criteria is for a pass-fail scenario. So let's go ahead and actually jump into Dynatrace and Ansible Tower and show what this looks like. So if I go to Dynatrace, I've been having issues with my cursor. Uh-oh. Sorry, everyone. This is a bad time for me to lose my mouse. All right, well, we're just going to work on the fly. If you see where I'm scrolling over, the response time here throughout has been 15 to 20 milliseconds, so it looks totally fine. I'll go ahead and switch over to Ansible Tower, and this is where my mouse would be really, really helpful. But I wanted to call out, you can see these 4 ET templates that I've built. There are the 3 pieces that I talked about earlier, and then one workflow template that just puts all of them together. This is very tricky, but it appears that I'm able to mouse over there. Sweet. So I'm able to mouse into my workflow mode, and you know what? I don't think I can do this anymore without a cursor. Let's see if I can somehow get this back. There we go. Sweet. Okay. So in the workflow visualizer, we see it just does the new deployment, checks the quality gate, and rolls back if it gets the thumbs down, did not pass. So let's go ahead and launch this. So in this pipeline, it's going to start by telling Dynatrace, hey, there's a new deployment event, and it's going to then change the configuration flag in the application. The reason that I push to Dynatrace a deployment event is because that's the easiest way for me to tell Dynatrace when to evaluate metrics. Otherwise, you'd have to say, hey, look at this time frame and then compare it to, I don't know, some other arbitrary time frame. So I use these deployment events just to keep track of, hey, a deployment happened, a deployment happened, a deployment happened. Compare this one to the previous one. So this one's green. It's all good. It ran. That was fine. Now we are at the check quality gate stage. Now in this stage, I actually have it sleep for 5 minutes before performing the query. Now the reason I have it sleep for 5 minutes is because in production, maybe you make that configuration flag change and it takes 20 seconds to kick in. And then you need a couple minutes of data to see how the behavior changes. We don't want to just compare an instantaneous metric now to before and then have that be our determination. We need a larger sample size. So in this case, I let it wait for 5 minutes and then perform the query. So let's move over to the Dynatrace side again, refresh this last 30 minutes and see what's happening. Nice. And I talked long enough so that you can see up here, Dynatrace found a deployment event. Here we go, enabling a new login authentication feature flag. This was from the first step of the Ansible Tower workflow. And you can also see that, yep, response time went crazy high. So now it's actually changed the graph so much that the previous request response time is all the way at the bottom because these milliseconds don't compare to this 11-second response time. So spoiler alert, and you probably already get where this is going. This is going to stay in a poor performing state for this entire time frame. So after the 5 minutes has concluded and we perform the test to compare the metrics now to the last deployment event, the perf signature is going to say we did not meet our threshold, and it is going to roll back that deployment. So in this case, let's just turn this into a real life example again. You have a developer, set of developers, your team, and you're building new versions of your app. You want to put it into prod, as opposed to people looking at the code and saying, the code looks good to me, it passed our integration test, let's just put it to prod. Now we're thinking about it from a performance mindset, and we said, run our integration tests, but then check how they performed and determine whether or not we should promote that. So here we can circumvent poor user experience. And if I were to tie this back to my first couple slides about T-Mobile data, the idea is that we don't want customers to have a bad time. We don't want them to not convert. We want them to enjoy our website and have a nice experience. So let's find these problems and block them before they get into production. Just like vulnerabilities, we don't need to wait and scan in production. We can check them early and make sure we're not putting ourselves at risk in the first place. Now, this is going to run, let's see, we are at 3.5 minutes, so it's probably going to take another 2 minutes before this step actually continues. As far as my presentation, I only have a Q&A slide and then a final evolving solutions slide. So at this point, this is actually going to be the end of my presentation, sans finishing the demo. So since we're waiting around, I'd like to ask at this time if anyone has any questions about this workflow or why you might use it or the pieces involved in it. Oh, there is a lot in the chat. Cool. Not related to mine though. All right, so I'm just gonna go ahead and let this run. We can see over in Dynatrace, it's still slow. Still up at this high response time. And actually, if we cheat and I look at the last 6 hours, we'll probably see me testing this morning. So what's going to happen is Dynatrace realizes there's a problem, but then we will have another deployment event where we disable that login authentication feature flag, and then the response time goes back to healthy. Then engineers could come in here and dig into the response time hotspots and figure out why was this so slow. So that is this third part, the rollback if spec failed. Now I was waiting to pull this up because I have an API key over here, but I'm going to delete this API key in about 5 minutes. So we can actually see the elapsed time, 5 minutes, 6 seconds. In this, there's all the script, but the call failed. There was an error. Error occurred when performing the perf signature. There was a metric degradation found. So the previous value that we expected was this 18,000 milliseconds, and it's in the 10 million milliseconds. So we've got a bad response code back from the perf sig. It said, do not pass this. And if I go back, this failed. So now this ran the rollback. And if we look at the last 30 minutes again, the deployment event has been pushed here, but I do not have enough integration testing, in this case, synthetic transactions running to have the very newest data. If I refresh again, we might have some. I'll give it one more try. We can see that it's starting to decline. And from the sneak peek, but what I did earlier, we know that it'll go back down to this fast response time. So why are we here today? What I wanted to share is one way that you can stop poor performing code from reaching production. So just keep in mind, how much does a production outage cost you? And how much does it cost you to fix a defect? And are you looking at the performance of the transactions that you are building? And are you evaluating those before you release to production? And if you're not, I would think about that and consider maybe moving a quality gate into your Ansible Tower pipeline. So I will save time for QA after I finish this slide. I'm sure that Keith is going to ask about it. So here you'll find my contact information and a link to our blog site. So in our Evolving Solutions blog, we have an EMA section, Enterprise Monitoring and Analytics. So far, I believe it's going to be released this week and next week. I have a Kubernetes instrumentation blog out there. It's also applicable for OpenShift with Dynatrace. And I know that we have an SAP performance blog that's being released right now as well. And then if you would like to follow us on LinkedIn, we share out all of the events that we have, like these types of partner events, plus any new happenings with technology and our customers in the Twin Cities. So thanks everyone again for your time. I appreciate you staying and watching. And let me know if you have any questions, but I'll go ahead and stop sharing.